Hello everyone. This is the third in my series of how to decompose a rational expression into partial fractions. This time I'm starting with a situation where I do not have a series of linear factors in my denominator. Now we need linear factors in the denominator before we do this decomposition. Our first job is to factorise this quadratic. Now if you're a bit rusty on these, I have a series of videos about factorising quadratics that you can go and review. So we'll just do this one pretty quickly. We have 4x, oh no, that's not 4x, that's 5x minus 4. Now when we're factorising, we need a number, we have a positive one at the front, so it's a quick one. We need numbers that will add to give negative 1, multiply to give negative 2. So that should be x minus 2, x plus 1. Let's quickly check by expanding. Negative 2 plus 1 is negative 1. Negative 2 times 1 is negative 2. It works. So now we have the situation that we need. We have two different linear factors. So we'll decompose this as a over x minus 2 plus b over x plus 1. And we proceed as normal from here. A times x plus 1 plus b times x minus 2, and our denominator is x minus 2 x plus 1. So looking back to here, we had same denominator, numerator 5x minus 4, numerator a x plus 1 plus b x take 2. Numerators must be the same. That's what we'll focus on. So we'll say this implies x minus 4 equals a x plus 1 plus b x take 2. How do we solve for a and b? Remember, x is a pronumeral. X can take any value we choose. I'm going to choose x equals minus 1 so that this term disappears. The choice of x minus 1 was not random. I looked carefully at what I had here to choose a value of x that would make this first term disappear. So remembering that x is negative 1 and substituting, I have 5 times negative 1 minus 4. This part's gone. B, and I have negative 1 minus 2. So that's negative 5 minus 4 is negative 9. That's negative 3 times b. It seems like b would equal 3. Going back to this point, I'm going to choose x equal 2 this time, for the same reason. Substituting, I have 5 times 2 is 10, minus 4. I almost did it all in my head, but that leads to mistakes, so don't be tempted to take shortcuts. And now this part here is a times 2 plus 1, so that's 3a. As we said, that bit would be nothing. 2 minus 2 is nothing. So we have 6 equals 3a, a equals 2, and then we write out our solution. The original expression we were given, 5x take 4 over x squared take x take 2, has been decomposed into the partial fraction 2 over x take 2 plus b was 3 over x plus 1. So the method is essentially the same as we did last time. The difference was we were presented with something that had a quadratic in the denominator, and we first had to factorise that to be two linear factors before proceeding through the normal partial fractions decomposition method.